Good morning, welcome to the Lionheart Academy. This is Richard Tai. Today we're continuing our trigonometry lesson number 53. We are starting to talk about vectors since our last video, and today we're going to go ahead and talk a little bit more about vectors. Now, just a quick review. What is a vector? A vector is a quantity that has is a measure that has both quantity and a magnitude and direction. So it's a quantity that has magnitude and direction. It has two things. It not just tells us how heavy, how big, or how long it is. That's in terms of magnitude, the strength, but it also has a certain direction towards where that magnitude, that amount is being applied, like a velocity. Okay, velocity is speed plus direction. So for example, velocity, like when you're driving on the freeway, if you say you're driving about 70 miles per hour, that is speed. But if you say I'm driving 70 miles per hour north, then you are talking about velocity. Okay, and so is force. Force are usually, it can be represented with vector, because force has magnitude, okay, the amount of force you're applying, and also a direction of the force you're applying. So the force is also a very good example of vectors. Later on, when we deal with application problems, we will be able to use both force and velocity to apply our vectors. Okay. Now, so last time we also talked about how to denote a vector, how to break vectors in component forms, and how to find the magnitude of vectors. We also talk about adding vectors and then scalar multiplication of vector operations. So today we're going to go on to talk a little bit about unit vectors. Okay, so today let's go ahead and start talking about what is a unit vector and what do we do with it, how to find it. Okay, now unit vector is a vector. It has the same direction as any non-zero vector v, but it has a magnitude of 1. Okay, so it's a vector in the direction of any non-zero vector v with the magnitude of 1. So what happens is, if I have any vector v, okay, if I just go ahead and draw any kind of vector, for example, if I just draw any vector like this, okay, now let's say this is vector v, and v can be the start from an initial point here and it goes in this direction. Now this vector v has a different kind of magnitude. It can have 10, 20, 30, or doesn't matter what the magnitude is. Now there's a certain vector u here that we can call, this is called the unit vector. Let's call this vector unit vector that is in the same direction of vector v, but its magnitude is 1. Now, in applications or sometimes in understanding, this is very important to have this kind of vector, so we can go ahead and use this to do different operations with this. So this is what the unit vector is. If this is a unit vector in terms of v, in the direction of v, then it will have a magnitude of 1, but in the same direction of v. So how do we find a unit vector in any direction? So let's say a unit vector is very simple. You take the vector v and simply divide by its magnitude. You divide by its magnitude. Okay. So how do you find a unit vector in any direction? A vector of any vector. Let's go ahead and you take the unit vector, divide by its magnitude. Or you can say I take 1, divide by its magnitude, and then multiply it by the unit vector. Okay. So let's look at the example of how that works. So let's say v is in the direction of -2, 5. Okay, so this is pointing in the third quadrant because x is negative, second quadrant because x is negative, y is positive. Alright, so to find the unit vector, first of all we need to find the magnitude of v. Okay, so the magnitude of v will be the x squared square root of x squared plus y squared, which is the same as Pythagorean theorem, or the same as finding the radius in a sinusoidal situation with x, y, and r. That's why we're all doing this in trigonometry, because it's basically just another triangle situation here. So this is 4, then this is 25, so this will be square root 29. Okay, so the unit vector of v in this case would be the vector v divided by the magnitude of vector v. So this would be -2, 5 divided by square root 29. Now, so this is another way of saying 1 over square root 29 multiplied by the vector v. So what we're doing here is actually a scalar multiplication. Remember, this is 1 over square root 29, just a scalar, so we're just going to multiply 1 over square root of 29 into the vector v, so it will be simply -2 over square root 29 and 5 divided by square root 29. And this is a representation of the unit vector. Now, this vector has a magnitude of 1. How is that so? Let's go ahead and check, okay? So the magnitude of this vector, -2 over square root 29 and then 5 over square root 29, is equal to, well, if we go ahead and do the magnitude, we have to do the square root, right? So we do -2 square root 29 squared, x component square, and plus the y component square. Okay, let's see what happens. I'm just going to show you the magnitude. Should be equal to 1. So this becomes 4, right? -2 squared is 4. Square root 29 squared is 29. 5 squared is 25. Square root 29 squared is 29. So this becomes square root of 29 divided by 29. And 29 divided by 29 is 1. So square root of 1 is equal to 1. Okay, so the magnitude is equal to 1. So yeah, so that means this is a unit vector. Okay, so we'll remember how to find unit vectors in the future. That it will be very important down the road. Now, let me introduce to you something else called the standard unit vectors. Okay, go ahead and just change it to a divider line here. Let me go ahead and draw a line here. Now, standard unit vectors. So if we look at our regular diagram, regular coordinate plane, we have two standard directions that we always use, which is called the x direction and y direction. And in those two directions, we also have unit vectors. Okay. Now, what do I mean by that? Well, it's very simple. So what we can produce is we can draw a unit vector from 0 to 1 in the direction of the x direction, and we can draw another unit vector from 0 to 1 in the y direction. So those two vectors will be called the unit vector. I'm going to call the green one I, and then we're going to call the red one J. So there's an I vector and J vector. The I vector, let me go ahead and put the I vector down here so there's no confusion here. So I vector is the green one and J vector is the red one. And I vector is the unit vector. So I vector is 1, 0, and it's the unit vector in the x direction. And the J vector is 0, 1, is a unit vector in the y direction. Okay, in the y direction. Alright, so why do we need to write this? The reason is, once we know we have an I vector and J vector, we can actually express every vector in terms of I vector and J vector. For example, V, usually we say, okay, it's V1, V2, right? So the V1 is the x component, V2 is the y component. So we can express this using another way, is V1 I plus V2 J. So this is another way, is very, very useful way to help us break down vectors into components, into a horizontal component and vertical component. Okay, so horizontal and vertical component. So V1I is the horizontal horizontal component, and this is the vertical component. Now, why do we want to do that? Because when we break down the components, it's very easy. It's easier to analyze and add and subtract and combine vectors. When we analyze vectors, when we break them down to components, it's much easier to do combinations in I and J rather than just go ahead and do it directly. But because actually that's what we have done already in a vector application. So when we do vectors, when we add and subtract vectors, we always use the horizontal and vertical components. But now we're just breaking down into two different components. Right? So we can go ahead and determine the vertical component. So let's say example. Alright, so let U vector, okay, vector U had, let vector U be the vector with initial point at 2, -5. I'm sorry, 2, -5, the initial point, and terminal point be at -1, 3. Okay, the terminal point be at -1, 3. So let's go ahead and find its component. So U would be equal to -1 minus 2, right, in our component, and 3 minus -5. That's how this is how we would do it, by subtracting the points from the initial points, terminal point minus initial points, to find its component form. So the component would be -3 and 8. Okay, so how do I express this using the I vector and J vector? Very simple. It's just -3i plus 8j. Okay, so breaking this down into two parts. Breaking it down into two parts. Alright, and how do we combine vectors using this? So for example, let U, okay, we're just going to let U used to be -3i plus aj, okay, and vector V be equal to 2i minus vector j. So let's go ahead and try to find 2u minus 3v. Alright, so how do I find 2u? Well, basically you take 2 times this, so it becomes 2 times -3i plus aj minus 3 times 2i minus j. Alright, so it's 2u minus 3j. And then because we are using component forms here, the I and the j vector forms, we just simply go ahead and multiply. And this is 2 times -3 is -6, 2 times 8 is 16, j minus 6i plus 3j, okay, and then all we have to do is combine like terms, combine the I vector with I vector, so it's -12i, and combine the j vector with the j vector, so it would be 19j. So it's -12i plus 19j. And we can know what this vector looked like very simply by, if we want to draw it, right? If we want to draw it, let me go ahead and draw this for you and show you what this actually would look like. All we have to do is we go -12 in the I direction, right? -12 in the I direction, and positive 19 in the J direction, and then draw a vector from here to here. That would be my 2u. This would be my 2u minus 3v. Okay, 2u minus 3v. So it's very, very straightforward, because the I vectors goes in the x horizontal direction and j vector goes in the vertical direction. Okay. Alright, now let's move on to one more topic for today, for this video. Alright, we're going to talk about the direction angle. Remember, we talked about vector, right? Vector has magnitude and direction. So we have talked about magnitude, and we talked about how to identify magnitude already. So let's go ahead and extend our discussion here now to then how do we determine the direction. So let's go ahead. Let me draw a vector here. I'll just draw a vector here. So this is a vector, and let's call this vector v. So vector v, we have vector v, v1, and v2. Another way you can write it, this is x and y. Sometimes people do that too, use x and y component. So we can go ahead and say it's xi plus yj, xi and plus yj. Just using the I component vector and j unit vector, I unit vector and j unit vector here. Now notice this I is I unit vector is not a complex number I. So next in the next topic we'll be talking about complex numbers. So please don't be confusing this I with the complex number I. Alright, so the magnitude based on this definition, which we already know, is square root of x squared plus y squared. Okay. I'm going to use x and y to call this v1, v2. So x here, this is y, okay. Alright, and if I go ahead and show you this would be the yi vector. The yi vector here is here, and then the yj vector, and then, yep, I'm sorry I said it wrong. This is the yj vector. Okay, the red vector, and the green vector is the xi vector. Xi vector. Okay, so going in this direction, and the yi vector is going in that direction, going in the y direction. Alright, so we can break it down into two components. That's great. We can find this magnitude, which is basically square root of x squared plus y squared. Now, what about the angle? So let's go ahead and call this angle theta here. Let's go ahead and call theta v. Okay, it's theta of angle of vector v. So how do I determine theta of angle v? Basically, what we know is we know the tangent of theta v will be equal to y over x. Okay, so tangent of theta v will be equal to y over x. That will always be true. That will always be true. So these two things will always be true. But how do you determine theta of angle v? Not angle v, excuse me, angle theta of the vector v. Well, we have to use arctangent of y over x. However, I need to put an asterisk here, because when you do arctangent, you if you remember, when we do arctangent only returns us the functions in quadrant 1 and quadrant 4. So if your vectors is in quadrant 1 and in quadrant 4, then you are fine. You can get the angle right away. However, what happens if the vector is not in quadrant 1 or not in quadrant 4? For example, like this vector. This vector is pointing to is in quadrant 2. It's pointing in the quadrant 2 direction. So that's why we need to, the asterisk is that we need to adjust according to, so you need to go ahead, let's go ahead and say note the quadrant, Quadrant. Note the quadrant of the angle, otherwise you will not have the correct answer. Okay, so let's go ahead and take a look at some examples. Alright, let's say v is equal to 3, negative 6. Okay, let's just go and do 3, negative 6. So the magnitude of v is equal to the square root of 3 squared plus negative 6 squared. Okay, so it would be square root of 9 plus 36, and that will give us square root of 45. Okay, 45, and we can simplify 45, square root of 45, because 45 is 9 times 5, so it will be 3 square root of 5. So that was the magnitude. Okay, now let's ask ourselves, before we can find the theta angle of v, which direction does this point to? 3, negative 6 is pointing to the 4th quadrant, right? Because 3 is positive, negative 6 is down here. So vector v, I'm doing a rough sketch here, vector v is pointing down in the 4th quadrant. Alright, so arctangent, we don't have any problems doing arctangent of y over x. Alright, so it will be arctangent of negative 2 basically. Okay, so let's do arctangent of negative 2. Okay, arctangent of negative 2. Let's see what how many degrees is that. Let's go ahead and make sure we're in degree mode. Alright, arctangent of negative 2 is negative 63 point, I'm going to round up to 43 degrees. to the 100th. Okay, so that's a negative answer because here that's giving us this angle. This angle is negative 63.43 degrees, which is good. Okay, so that's the correct answer. We don't really have to change it. But if you want to express this using a coterminal angle, a positive coterminal angle, let's add 360. So if I go ahead and add 360, I will get 296.57 degrees. So 260.57 degree will be coming from this direction. That will be 296.57 degrees. Now it depends on your application. How do you want to express this? But usually we will express using the positive angle, but we can use a negative angle also. In quadrant 4 and quadrant 1, you don't really have to do too much. Alright, let's go ahead and try another example where it's not in quadrant 2 and quadrant 4. Okay, so let's say, oh, I forgot to put the vector v here. Let's say vector v, let's use a different vector. Let's say vector u, excuse me, is negative 5i plus minus 6j. Okay, negative 5i minus 6j. So let's first determine the magnitude of u. Right, so let's do square root of negative 5 square plus negative 6 square. Alright, so negative 5 square is 25, negative 6 square is 36, and let's add them up. Square root of 61. Okay, square root 61. I think square root 61, we won't be able to simplify it. Yeah, square root 61, so that is that. Now, what about the angle of theta u here, the theta of vector u here? Now, because it is in quadrant 3, right? Both x and y are negative, so it's negative 5 here and negative 6 here. So this is what vector u looks like. This is what vector u look like. To determine the arctangent and to determine the angle, we have to do something a little bit different here. All right, you see. The reason is, let's go ahead, if we just do arctangent of 6 over 5, right, negative 6 divided by negative 5 and do the arctangent, we will get an angle of 50 degrees, 50.2 degrees, 0.19 degrees. But 50.19 degrees is in quadrant 1. It's actually here. This is actually 50.2 degrees. I'm just going to round off right now. So this is not the right angle clearly, but yeah, as you can see, because those two angles, they're back to back. They're actually they're actually on the same line. They have such a property. So the arctangent of this ratio is giving us this angle 50.2 degrees in quadrant 1. So what do we have to do? Well, as you can see, the difference between 50 and this angle is there is an extra 180 degrees. So what we need to do is we need to add 180 degrees here to our 50.2. So if I add 180, that will give us 230.2 degrees. Okay, 230.2 degrees. And that's exactly what our answer should be, 230.2 degrees, which is in quadrant 3. So if your angle is in quadrant 2 or quadrant 3, you have to remember to add 180 degrees, okay, to your angle. So let me go ahead and summarize just a little bit more. Okay, so if vector v is equal to x, y, okay, like that, or equal to x I vector plus y j vector, the magnitude of the vector is always the same. It's square root of x squared plus y squared. Doesn't matter what x or y could be, either positive or negative. But the angle of theta v will be equal to arctangent of x and y, y over x, excuse me, y over x. Now this is if vector v is in quad 1 or quad 4, or the direction, I should say the direction of, if the direction of vector v is in quad 1 and quad 4. Now if it's in quad 3 or quad 2, second quadrant or third quadrant, you would do well to add 180 degrees. Alright, so This is a basic rule of thumb. However, this always the formula that most textbooks gives you always writes out like this, and this is always true. That is always true. Now this depends on the quadrant, so we have to be careful when we do the arctangent. When we do tangent of theta, we always will get y over x no matter what. That's for sure. But if we do arctangent or y over x, we have to be careful of where our vector is pointing to. So that's the most important thing that we want to make sure we go ahead and do so. Okay. All right. So I think next video we'll stop right here. Our next lesson, we'll be talking about some application problems that we can do with vectors by finding directional angles and magnitude and things like that. Okay. Now, if you have any questions and comments, please leave your question. Make sure to leave your questions and comments in the comment section, and then please remember to subscribe and share this with your classmates and other people. And we thank you for joining us. We look forward for you to join us in another lesson of trigonometry. Thank you.